Hi, welcome and thanks for listening. In this talk, I would like to discuss some of our recent work on what is visually salient from an individual cognition point of view, and also what becomes conversationally salient as it is mentioned during a dialogue. When we use language to discuss and to talk about visually grounded content, right? When we use language, for example, to describe an image, to describe a scene, right? Or to refer to something within a visual scene, there are several constraints that may play a role, right? So, for example, there are generic cooperative principles that play a role. We are expected to say things that are true of that visual content that we are describing. If we intend to refer to something and discriminate it from something else, we expect to be informative enough for this to take place. But besides this kind of generative principles, general cooperative principles, there are other types of individual constraints that also play a role. For example, the level of lexical availability that we may have as individuals, right? In this example descriptions here, you can see that one of the speakers refer to a man as playing a trumpet. This is rather specific, while another participant just to say a man playing an instrument, which is more generic. And this may be related, driven by different types of lexical availabilities that these particular speakers have in mind. And there are also aspects that play a role that are related to visual saliency. And on top of that, there are also constraints that come from social interaction. Right? So what becomes salient in a dialogue may play an important role on how we choose to describe something or to refer to something later on in that conversation. So I would like to start by focusing on these individual constraints and on visual saliency. And then in the second part of the talk, I'll move on to talk more about these interaction-driven constraints. So, there are theories in cognitive science that look at cross-model alignment, the alignment between the linguistic and the visual modalities in the linguistic production processes, right? And cross-model theories tend to say that visual information processing guides linguistic production. Right? So that there is a cross-modal coordination between language and vision that unfolds sequentially as we produce language. And to put it simply, this is definitely too simplifying, we could say that objects tend to be looked at before being mentioned. Right? The relationship is not so clearly linear, but this is a bit the idea behind theories of cross-modal alignment. Right? And yeah, so we wanted to investigate a bit further how we could model this type of cross-modal alignment where both language and vision are treated as sequential modalities, which is what they are, right? So we consider the task of describing an image, of image captioning or image description, and we exploit eye tracking data, which tell us what is visually salient at a given moment for an individual, to produce word by word a description of the utterance. Right? And of course, as you're aware, eye tracking data to model visual saliency is something that has been used extensively both in computer vision and also in NLP. But typically, we tend to aggregate these to have a general notion of saliency over an image, while here what we try to do is to exploit the sequentiality of the scan path that an individual goes through when scanning, visually scanning an image at the same time as producing a description. For this work, we are using data in Dutch, which is also a little bit challenging, but also interesting to be using data that is not English as we commonly use. And we use a really nice data set developed by colleagues in Tilburg of Dutch image descriptions, spoken descriptions that are aligned with eye tracking patterns, right? So by using the timestamps of the spoken transcription, we can align the different words as they are being produced with what the participants are looking at, right? And then our goal is to model this, to model the interaction between these two modalities taking the scan path as input and trying to predict what will be said by that participant that is scanning the image in this particular way. To do this in a computational manner, what we do is to adapt the image caption generation model by Anderson et al., the bottom-up, top-down attention model, to incorporate gaze into the model. And the way in which we choose to do this in this particular work is to include the gaze as input to the model. So in the encoder part, at each time step, we will concatenate the linguistic input with a vector that represents the visual features of those areas in the image that are being fixated by a given participant at that moment in time. Okay, and this develops sequentially in this manner, right? And then we compare this setup to different setups where we would either not have gaze at all, like the original model, or where we could input gaze in an aggregated manner without this sequentiality of the scan patterns. One question, of course, is how to evaluate the goodness of fit of the descriptions that are being generated in this manner. And given the cross-model hypothesis that we take as our starting point, the idea is that if we use the scan path, the visual saliency of a particular individual, this should lead to descriptions that are more aligned, not only semantically, but also sequentially aligned with what that speaker actually ended up producing in terms of language, right? So we developed a metric that aims to capture this idea. I will not go into details, but I hope that the general idea is clear. It's a matter of measuring how well semantically and sequentially aligned the given produced description is with respect to a reference, right? And this is a distance metric. So the key results from this work is that we observe that the models that do exploit the gaze sequentially, they lead to more human-like descriptions, right, in terms of this metric that I just mentioned, right, in terms of this distance metric. And what we also observe is that they learn a much larger vocabulary than models that don't exploit gaze, right? And furthermore, that they are able to produce more varied descriptions for a given image. Because recall that I just mentioned that we produce a description for the scan path of a given individual. So we see that indeed, if we change the visual information, then this leads to changes in the output, meaning that this visual information is indeed being used by the model. I mentioned here that this is particularly the case when we use an additional recurrent component, and I can give you details about this, but the idea is that when inputting the gaze pattern, the gaze information, we can do this also by having a dedicated LSTM and not directly inputting the visual features, but rather the hidden states of this gaze dedicated LSTM. And this allows for a more flexible alignment between the two modalities and leads to slightly better results. So just to show you a couple of examples of the types of descriptions that are being generated. So we can see here that one of the features that we observe is that when we do provide gaze information to the model, then we have more specific descriptions, right? So in this case, this would be the description generated by a model without access to any gaze information, and this would be the one generated by our model. And we can see that here, for example, the donuts that are inside here in this trunk of the bakery are mentioned, so it's more specific. This is in line with the idea that the vocabulary is also larger, right? So we observe this. And another interesting aspect that we observe is that our models sometimes produce hesitations, like field pauses, some types of disfluencies that are present in the human data, which is originally spoken, right? And so regardless of whether you think it's a good idea to generate descriptions that include these hesitations, I believe that this indicates that indeed the possible uncertainty present in the visual scene that had led to some hesitation in the output is in fact being also experienced in some way by the model, and this is reflected in what the model is producing. So I think this is an interesting aspect that could definitely be investigated a bit further. All right, so I hope this gave you a bit of an idea of what this kind of work is attempted to do. I'm just going back now to my first slide, right? So I've talked a little bit about these individual constraints with, in particular, the notion of visual saliency by one speaker that is driven by the scan path of where this speaker is looking at. I would like now to move on to more interaction-driven constraints, right? On how the common ground that is being accumulating during conversation may also provide constraints on what makes sense to say and how to say it when we talk about visual content. So indeed, when we are referring to material, to aspects that are in the visual scene, in conversation, we often do that more than once, right? So the same entities may come up in the same dialogue, right? So besides these more individual cognitive constraints that we have just been talking about, of where we look first and so on, also the way in which things are mentioned in the dialogue are going to have an effect, as I have been saying, right? So for example, we may have a dialogue where one participant decides to refer to this image here as a white fuzzy dog with a wine glass. The next time that these participants will encounter this particular image and want to refer to it, they may choose again something like the wine glass dog and then go on to use again the wine glass dog, right? This is of course not the only way in which we can refer to this image, right? A different pair of participants may start by referring to this dog as white dog sitting on something red. Right? If that's the case, if it is this precedent in the conversation, then it is much more likely that they will continue with the dog on the red chair than rather that they would suddenly choose something like the wine glass dog, right? So what the way in which we formulate subsequent mentions seems to be strongly linked to what has happened before in the dialogue, besides any individual cognitive constraints or visual features that also obviously constrain what we can say in a truthful and informative manner. This type of phenomenon, not so much in the context of multimodality, but more generally in cognitive psychology, has been discussed extensively in experiments that have been carried out in the lab, right? So since the 60s, in fact, right? And in order to investigate this type of phenomenon, we decided to create a data set that would elicit this re-referring acts to the same type of visual content. So a couple of years ago, we created the photobook dataset, and this is a visually grounded dialogue dataset in which we have 2 participants. Each of them has 6 photos. Some of these photos, some of these images are in common between the 2 participants. Some of them are not. And then they can chat freely. They can just go on with the dialogue freely in order to find out what are the images that they have in common. Right? So for example, here you see an example dialogue. And in this case, after this little exchange, then participant A is able to indicate that this image apparently is in common between both participants. Now, a key feature of this data set is that this kind of game, this reference game, goes on over several rounds, over 5 rounds. You can see here that this would be the first round of a game of 5 rounds. And over these 5 rounds, some of the same images reappear. This means that the participants have the opportunity to re-refer to this material, right? And like this, we can investigate how much the conversational precedents have an impact on how they decide to refer to these images. So we can then extract in the ways in which they refer to a given image in each of these rounds of the dialogue. So for example, in the first round, we have seen that this image could be referred as, I see a guy taking a picture, what about you? And then as the game proceeds, in the second round, maybe in this case, participant B finds the image and then they refer to it as guy with camera. And then the game continues. The third time I have the guy with camera. The last one is the guy with camera, right? So we have then a chain, what we call a referring utterance chain of different ways in which the participants within that dialogue have been referring to the same image reference, right? And this is, of course, an order chain. So using this type of data, the first thing that is interesting to do is to look at what are the patterns that we observe in the human data when we look at these reference chains in which participants are re-referring to the same content, right? And the patterns that we observe are very much in line with what had been observed in the early studies in the lab with slightly different experiments, but very similar one. The famous tangram experiments by Clark and colleagues, if you are familiar with that. So they reproduce quite a bit those kind of patterns, which is a good sign, given that this was collected at a large scale with crowdsourcing. And essentially what we see is that as the participants keep re-referring to the same type of referent, that the utterances, the descriptions become shorter. So that's you can see in the first plot. So the utterances become shorter. Then as they become shorter, the type of words that seem to remain are mostly content words. So there is an increase of content words ratio, right? While other more function words tend to be dropped. And if we look at the distribution of part of the speech, part of a speech within, well, a mix of content and function words, we see that it is mostly nouns and adjectives that increase in this domain. This might be very well domain specific, right? And finally, in the last plot, we see also that there is a sharp decrease of new content words. So basically, if we start referring to something as the wine glass dog, we are likely to stick to it and not introduce new content words. Right, so rather entrain, so we tend to entrain lexically on the kind of words that we have already used, even though other words would be fine as well, right? And we can observe that in a different dialogue. But within a dialogue, within two given dialogue partners, we tend to entrain on the same lexical content. So this is what we observe in the human data. And then moving further onto how we could model this computationally, the question that comes to mind is what would be the contextual representation mechanisms that would support these patterns, right? That would allow us to reproduce these human patterns because they seem the natural way to refer. And so in this work in which we address this question, we propose a range of different generation models that offer possible hypotheses for what these contextual representation mechanisms may be, right? So we can think as the most simple model, as a model that does not take into account conversational context. It just refers to an image. So given a set of distractors and a target image, it just tries to provide the most discriminative utterance possible, but it does not take into account previous mentions. It's just a model that refers, right? On the other side of the spectrum, we could consider a model that does not take into account the visual context, right? It just takes into account the visual features of the target, right? But and only sticks to what has been said in the conversation. So once the participants have referred to that particular referent in the conversation, then in subsequent mentions, we can just repeat what has been said before, right? Without taking into account whether the visual context has changed or any other type of pressures, right? And then finally, a model that in principle we think is a good candidate to reproduce the patterns that we have seen would be a model that of course takes into account both what's in the visual context, what are the distractors, and also what's in the dialogue context, what has already been said about that referent, right? So it is aware of previous mentions, and therefore it's not only referring, it is re-referring if there had been previous mentions. The way I'm going to just focus, I'm going to focus in terms of results on these two models that, since this one is the best performing one, right? And in the way in which we operationalize this re-ref model is essentially, so these are all encoder decoder models, right? So the re-ref model, essentially what it does is that at the encoding stage, it does not only take into account the visual context, but it also encodes previous references, which we assume are kept in memory, right? Which is in line with some cognitive science theories that would postulate that this is a possible mechanism that is behind this, right? I will not give you details of the model here, and I refer to you to the paper if you are interested look into that, just in the interest of time here. So we have these different model possibilities. I'm focusing, as I said, in the ref and the re-ref models. And then, of course, one question that arises is how could we evaluate this? And ideally, obviously, we would like to evaluate it maybe with human evaluations, but this is not what we do at this point. Right? So one first question that we can ask is how similar are the generated utterances to the human utterances we find in the data set, right? And we can use classic generation evaluation measures like plus, either, etc., which we know don't correlate sometimes so well with human judgments, but still it's not a bad step to start with this. Right? And here in this first plot, you see BERT score in particular, and basically what you can see is that the re-ref model has slightly higher scores when it comes to similarity with human utterances, right? Both in the first time that the first descriptions, the first time that the participants are referring to something, and when they're subsequently referred to it, right? A next question that we can ask is how effectively do the generated utterances fulfill their referring goal, right? Not only how similar they are in terms of surface structure, but are they actually able to allow a human participant, well, a listener, to identify what's the referent, right? In this case, we don't use human participants for this, but we implement a resolution model as a proxy for a human listener and check what's the accuracy of that model. And then again, we can see that the utterances generated by the re-ref model are easier to resolve as well by this listener model. It's also very interesting to look at what are the linguistic patterns of the generated utterances. That's also a way of indirectly evaluating, analyzing what is being generated. Right? So we saw very specific patterns going on in the human data. To what extent are we able to reproduce these patterns without automatically generated referring utterances? And so we can look, for example, at the lengths, right? And basically what stands out here is that the patterns that we observe with the re-ref model are much more similar to the human participants than what we see with the ref model, right? And this indicates that there is a shortening, as we saw before. The initial descriptions are longer. As we re-refer, they tend to be shorter. The second plot here shows the proportion of nouns, which we had seen that typically increases. Again, the pattern that we see between re-ref and human is more similar than with the ref model. And finally, this third plot shows the amount of content words that are being reused in subsequent mentions. Right, so this idea of reusing of lexically in training. And we see that, again, these are more similar in that in fact, the re-ref model does this to a larger extent than humans. I've put an example here at the bottom, just out of curiosity. So this is an example where the previous human mention was a cake with a Godiva package in the background. Our re-ref model generates as the next referring utterance chocolate cake with Godiva in background. So you can see that there is a lot of reusing. There is also some shortening. To conclude, I would like to mention the phenomenon of noun-noun compounds, which are a very interesting type of mechanism that is commonly exploited by the human participants, right? So to create a compressed, a very concise noun-noun compound that somehow puts together what has been said before in a more expansive way, right? And so this is an example by the humans that we have already seen before, how we end up with the camera guy, right? From guy taking a picture. So we wanted to check, we checked at the qualitative level, whether our models are also generating this kind of noun-noun compounds. And we observed that, yes, that they do. So we may go from lady with basket to generating something like basket lady, right? And in this case, we can see that this utterance, basket lady, seems to be accurate according to the visual context. At least it seems to be truthful descriptions of what we see in the image, and is also coherent with the conversational context, right? Because we are reusing words that were here, we are dropping the function word, etc. Sometimes we also observe something like this, right? Where we go from, do you have headband guy, to an utterance that is tattoo guy, right? Taking into account the visual context, this is no problem, because in the image, indeed, we have a person who has both a headband and a tattoo. So that's okay, that's accurate, right? But we may wonder to what extent this is accurate, coherent with the conversational context, right? So are we breaking a particular conceptual pact? And it is a bit of an open question how much a human participant would be surprised by this, or whether there may be other visually relevant aspects that make this in fact appropriate, right? So I will leave it that there as an open question. And I will conclude here. So thanks a lot for your attention. I would like to thank also the team members involved in this work. And I look forward to discussing further at the VQA workshop.